to the first session of our series on Advanced Java. Here we will introduce ourselves to the Java Enterprise Edition. Distributed applications. We'll then explain client-server model and important terms related to it. Let's start with Java editions. There are predominantly three editions that Java works with: the Standard Edition, the Enterprise Edition, and the Micro Edition for handheld devices. The Standard Edition is the core Java programming platform. It contains all our Java libraries. The Java Development Kit, or the JDK, is part of the Standard Edition. The latest version is JDK 8, and it helps to develop and deploy Java applications on desktop, servers, and embedded environments. It is also used to build standalone applications. The next is the Java Enterprise Edition. The Enterprise Edition platform is designed to help developers create large-scale, multi-tiered, scalable, reliable, and secure network applications. The latest version is Java Enterprise Edition version 7. It is portable, so it allows an application hosted at one common place to be accessed by users across the world over the internet. It provides application programming interface to develop distributed applications that allow the client-server model. It also facilitates the development of web applications. Next, we have the Micro Edition. It's a technology that allows programmers to develop programs for mobile devices. The latest version is 8.3, and it consists of programming specifications and a special virtual machine, the K virtual machine, that allows Java ME encoded program to run on mobile devices. The Java Enterprise Edition differs from the Standard Edition in terms of the libraries it provides to deploy fault tolerance, which means that in case there is an error, there is capability of your database transaction or something to roll back, so your data is always in a consistent and durable format. It ensures that there are libraries so that you can develop distributed applications. Distributed applications would mean part of the processing being done on the client, part of the processing being done on the server, or also the processing load being distributed across multiple nodes. We have multi-tiered Java software, which is basically based on modular components running on an app server. So we can create an application server and deploy some code over there which can be commonly called from multiple clients. Now, built on top of the Java Standard Edition, Java Enterprise Edition provides additional libraries for database access via JDBC and also for persisting data using the JPA API, remote method invocation, where you can have some code on a remote machine and call that code remotely onto multiple clients, so that if there are changes to or updates to the code, you just have to update it on a central system. You have messaging done by JMS. Messaging would mean when you're sending information from one application to another remotely, and that application probably is not live and active when the communication is happening. In that case, your data can be stored in a message queue, and the moment the end application becomes active, the data will be received there. Very similar to an SMS. When you send an SMS to your colleague, and if the colleague's mobile phone is switched off, in that case he will receive the SMS when he switches on the mobile. Until then, the message will be stored in a queue. Web services and also XML processing. And it also defines standard APIs for creating enterprise Java beans, server-side servlets, portlets, and server-side scripting with JSP. So here is how the enterprise architecture looks like. We have a client which is connected via a web browser. It's connected to a web server. On the web server, we have our server-side code which is set up, which could be written in servlets or JSP. And here we have a controller. So here we can implement a model view controller pattern, where the controller will accept the request and pass it to the appropriate view, which should be returned to the user. If there is some business logic to be processed, it can be pushed to an application server, on which we can have an EJB container which has your data model. So the controller can be here, which can pick up data from the model class which is connected to the database. And the benefit of isolating common code on this application server is you can have different UIs connecting to the same code. In case you have a desktop based GUI application that also needs to use the same processing business logic, it can simply go ahead and call that EJB or the enterprise Java bean code that is hosted on the central application server. So that is reusability at its best. The Java Enterprise Edition platform facilitates an architecture in which the business components are placed in a separate tier as we saw. It also enhances features such as better scalability, where you can enhance the number of users accessing your application easily. You can extend the capability of your application, and also maintaining the application is easier because any change is isolated to just one box in the deployment strategy. Its modular design allows easy modification of business logic. It provides more security because it partitions business services from the web tier. It also permits clean job separation of job roles. The enterprise component can also leverage their EJB container for service such as component and resource management, better security, better persistent, and also transaction management. So here you see that there is a scale going from left to right which manages complexity, and a scale going from the bottom to top which looks at robustness. I can develop an application and host it on the server side purely in HTML. In that case, you cannot really create very complex apps, and it's not very robust as well. On the other hand, we can create a basic JSP and a servlet page. If I create a basic JSP and a servlet page, it consists of HTML pages, JSP pages, and servlets. You can create fairly complex applications using this, and they are fairly robust as well. The next level, you can create JSP pages with modular components, where it consists of HTML pages, JSP pages, servlets, Java Bean components which are deployed on a application server, and a set of custom tags. In that case, the complexity increases and the robustness also of the application increases. Finally, you can create an application with HTML, JSP, servlets, the application server hosted Java Beans, custom tag, and also enterprise Java Beans, which give you better security, maintainability, better object management, etc. In this case, you can create highly complex and highly robust applications. The key points here is, as the richness and robustness of web applications increases, so does their complexity. The complexity of the application can be managed by proper design that helps in getting rid of programming concerns. The Web Container in Java Enterprise Edition platform provides components that can be used to manage such complication or complex application design. Let's go to distributed applications and the client-server model in Java Enterprise Edition. Here we'll talk about distributed apps, client-server model, the HTTP protocol, types of server responses, client request types, HTML, and running HTML code with Apache. Java Enterprise Edition provides an API to develop distributed applications that follow the client-server model. So part of the application can be hosted in the server, and part of it can use the processing speed of the client. In distributed applications, same applications can run across different machines at the same time using the internet. One machine acts as a server where application is deployed, and the other machine acts as a client. So here you see a server with multiple clients connected to it, and all these servers are further connected to each other using the internet. So we are actually using the processing speed of multiple nodes, multiple clients and servers which are spread across our connected network, and hence the application will perform much better. It will execute quicker because of the processing speed that is well distributed across the available nodes with us. The client-server model is a distributed application structure that partitions tasks or workloads between the providers of a resource or service and service requesters. Both web client and web server are actually programs. Now the web client is not a user. It is actually a program. Someone who uses this program to send requests to a web server is known as the end user. Here we see the architecture. There is a client which could be a web application, it could be a chat application, which sends a request to the web server. The web server would be something where it hosts a web application, a database application, could be an email server. In response to that, the moment we send an HTTP request to the web server gives us a response. One cycle of request and response is termed as a postback. Here we see we are making a request to HTTP. We are saying HTTP localhost 8080, which is the port on which your application is hosted on the web server, and we are providing an application name. This application name is a custom application name of your choice that you can host on the web server. The web server accepts requests from the client and gives back a response which can be either static or dynamic. I can return a static page in response to this request which will be hosted on the web client, or I can return a dynamic page where, depending on the request received, for example, if I accept the user ID, based on the user ID accepted, I can provide an attendance page or an account detail page to the client. And the responses that you are provided to the client being a browser, are always in the HTML format. So this request and response is typically working on the network on the HTTP protocol. The HTTP protocol is a TCP/IP based protocol which is used to deliver data on the web, and it provides a standardized way for communication. So we can focus on the business problem and we don't have to worry about how data is going to be sent between the client and the server. The uniform resource locator uniquely identifies a resource on the internet. So here you see the protocol, the name of the machine on which the application is deployed, the port number on which the server is listening, and the custom name of your application, which is the root folder which holds the app inside. If you're using Apache Tomcat server, it typically runs on port 8080, and you can also configure it, so remember to check during installation. Here are the features of the HTTP protocol. It is a TCP/IP based communication protocol which is used to deliver data over the web. So the moment you send data, you can be guaranteed that this data is received at the other end. You do not have to bother about checking that. The protocol is used to change or transfer hypertext. So you can send HTML or hypertext markup language. Hypertext is a structure of text that uses logical links between containing text. It is a stateless protocol, which means it does not remember what it last did. You cannot send information and expect it to remember what it last did. So that is not the job of HTTP. For example, if a postman is delivering letters to your home, it is not his job to read the letter and remember the contents of the letter. If the postman or the courier guy starts doing that, he would reduce the number of letters he would deliver per day, and that would impact performance. The job of the courier guy is just to ensure that the letter is taken from point 1 and delivered to point 2, and he forgets about it, and hence HTTP is a stateless protocol. The server generates response for client requests. It sends three things: the status code, which tells the whether the client's response has successfully reached the server or not. Example, a 404 response would indicate the page is not found. Information about the type of content the server is going to send, which is the metadata, so that the client browser can prepare itself to display videos, flash files, audio content, etc. And actual content, for example, google.com, if I put it in any browser, the server will go and navigate to that particular HTML content which is hosted in this particular URL. There are different server response types. I can get a static page where it's just a flat file that comes from the server, which could be a CSS file, a JavaScript file, or a JPEG file. Or I can have dynamic content where, depending on the ID of the user or depending on the login ID, I will get a customized home page or a customized map page, etc. So either you can generate a page on the server at runtime on the fly and give it to the client in HTML, or you can just save a static CSS JS page on the server which is given to the client. You can have a static page on the HTML file on the server which is given to the client. So as we see here, there are two options. We can either have a static page which is displayed on the client that is generated from the server, or we can have a dynamic page that is generated by the server on the fly. So the static page is just a flat CSS or JS or JPEG page that is on the server that can be displayed on the client, or you can have a dynamic page that is generated on the fly by the server and displayed onto the client. The commonly used server types are as follows. We can have a web server which responds to HTTP protocol and gives HTML content. We can have an app server which executes some business logic on the server and gives a result. A proxy server where we can set security restrictions. It's a virtual server on which all the clients can connect to the proxy server first. You can have policy rights, access rights defined on the proxy server, and then that assists you with communicating to the outside world. Virtual servers which use virtualization, physical blade servers, file servers that look at saving files, and policy servers that look at implementing some security policy across the organization. Let's look at the difference between web and application server. Web server runs on the server. It looks for incoming requests and services. Those requests, once the web server receives a request, depending on the type of request, it might look for a web page or execute a program. Web servers have plugins to support scripting languages like Perl, PHP, ASP, etc. and they can generate dynamic HTTP content. It acts as a container which serves static content. Web servers only support servlets and JSP. Application servers, it is a component-based product, provide middleware services for security and state maintenance along with data access and persistence. Application servers can do whatever web server is capable of doing, as it has web server as integral part. Additionally, it has components and features to support application level services such as connection pooling, where you can have a set of connection objects created so that you don't have to spend time to wait for the object to be created and destroyed in memory. It will create a set of objects and simply reuse them. When you finished using the connection, it will move that object into the pool so it can be used again, so it does not have to destroy the object and recreate it, and hence performance is better. Object pooling also, so if you have some code on the server side and you want to generate objects out of it, you don't have to fire the constructor and initialize memory each time. It will just create an object, maintain it in a pool so that you can use, and the object is sent back to the pool, and this feature is given to you by the app server. Also transaction support and messaging services, so in case your component is offline or if you're trying to connect to a service, it will store that message in the queue, and when that service or destination endpoint is active, that message will be picked up and submitted there. It also acts as a container upon which business logic is built, and application server supports distributed transaction and EJB. Here are the HTTP verbs to which your client can request. The client can send either of these requests to the server using the HTTP verbs. Get is used to get the resource. It can send limited data. It's not secured because your data is visible in the URL, and it is the default method for communication. Post is used to process data that is sent via a form, etc. It is secured because it cannot be bookmarked. There's no limit on the data sent as payload, as it is not appended in the URL. It's sent as the body of the message. If the URI refers to an existing resource, it is modified. If the URI does not point to an existing resource, then the server can create the resource using put. It replaces all current representation of the target resource, so you can upload new content on the server. If you want to delete, you can delete content on the server using the delete verb, and it allows eventual consistency while replication. Deleted documents remain in the database forever. You can trace request, which is used when the client wants to see if any change has been done by the intermediate server, and this request works for targeted resources. Option request returns the HTTP method which is supported by the server. It allows the client to determine the option requirement associated with a resource. The head request is used for testing hypertext links for accessibility, validity, and recent modifications. This is similar to get method, but it asks for response without response body. HTML stands for hypertext markup language. It refers to the way the web pages are linked together. The link available on a web page is called hypertext. HTML contains tags and elements which are used to format web pages. A typical HTML document has the following structure. So you can see doc type HTML indicates we are using version 5. You have the HTML tag, you have the head tag and the body tag, which typically contains the title. This is the standard structure of an HTML file, and you expect this as a response to any servlet or JSP code that you have on the server side. So you open an editor, you write HTML code, you save it with an extension in the drive of your system. You just double click on the file and it will open the HTML file if you just want to access it on your local system. If you want to deploy your content using a web server which will give you HTML response from the server to the client, you install Apache Tomcat. It typically has a couple of folders in it, and inside the web app folder you create a project folder and you put your HTML content there. So when you hit a URL from the client using the port number of the server, you will get that HTML response back again. And we will be looking at this in the subsequent sessions as we do hands-on for Apache installation and server-side deployment. So you create a subfolder in the web apps folder, then you add a name to your project, you put your HTML page inside it, you open your browser and you hit a URL which is localhost, port number of Apache server and the project name. And that is when it will return the name of your HTML file which is hosted on the web server. Here is a screenshot of web app. So in the Apache Tomcat folder, we've created a project folder, and that is where we will put our HTML content. At the end of the session, we've understood that Java has 3 editions: Standard, Enterprise, and Micro. The Enterprise edition differs from the Standard edition in terms of libraries it provides to default, fault tolerance, better deployment, better distribution of processing load and multi-tier Java software. In distributed applications, same application can run across different machines at the same time using internet. One is client and other is server. The client-server model is a distributed application structure that partitions tasks or workloads between the providers of a resource or service like a web server and service requesters, which are web clients.